So people who imagine that an LLM is something bigger, that LLM can imagine something new, can be creative, they cannot just imagine how large the training data set that was used to train it is. People often test LLMs by they know something. Oh, okay, I will ask it, we'll see if it knows it too. And yes, it knows it too. But it's just because your knowledge is so unoriginal that of course it knows it, because it was already in some documents written by others.
Hello and welcome to the show. I'm your host, Jason Knight, and on this podcast I speak to a motley crew of inspirational thought leaders and practitioners to give you the insights you need to build the best products and the best product companies. Now, if you want more of that, well, you're in luck. You can head over to onenightinproduct.com, where you can find links to all my past episodes as well as my insightful newsletter, and even a link to come and hire me if you need help sorting out your product organization. On tonight's episode, we try and cut through the hype of large language models with someone who actually knows how they work. We speak about where they came from, how they work, what they're good at, and what they're not. And we also dig into AI agents, whether there's any chance of them living up to the hype and putting everyone out of work for good, and ultimately try and answer the question: are these agents more like James Bond or Austin Powers? For all this and much, much more, stick with us on One Night in Product. So, my guest tonight is Andriy Burkov. Andriy says that, just like George Washington, he never tells a lie. Now, I don't know if that's true, but he's definitely trying to put his money where his mouth is by telling us all the truth about generative AI through his in-your-face LinkedIn posts and newsletter articles, as well as writing all about it in his various books. Now, there are plenty of people out there trying to shed some light on the industry and see through the hype, but some of them probably know about as much about how this stuff works as the aforementioned George Washington. But not Andriy, who's got a PhD in artificial intelligence and is the author of 3 books, including the new 100-page language models book, which has roughly 100 pages, and I'm hoping he's not about to tell me that he wrote it all using ChatGPT. Hi, Andriy. How are you tonight?
Hi, Jason. Thanks for having me. I'm doing good. Actually, yes. So the book is slightly over 100 pages. But, I always explain to people that it all depends on the format. So, for example, if you use an ebook, it's 200 pages. If you use a paperback, it's one format. If it's hardcover, another format. So, like, more or less, it's around 100, but you cannot really guarantee like exactly 100 pages. But it's less than 150 in most editions. So if you round it, it rounds.
Yeah, I guess it's like with LLMs and stuff. You can never quite guarantee the output, right? But,
Right.
all you can do is do your best.
Yes.
Now, normally I would start with a really softball question and say, oh, hey, Andriy, how are you doing? Like, what is it you're working on these days? What are you doing for your day job? But you've just this very day put something out on LinkedIn saying that you're changing everything up. You're going in a new direction. So, hot off the presses, why don't you tell us a little bit about what you're going to be doing from now on?
Yeah. So it was not an easy decision, because I've been employed for exactly 20 years now. So when I moved to here in Canada in 2005, I didn't have a job. Then I joined university as a full-time student. I've got a scholarship. And then after university, I joined Fujitsu and then Gartner and so on. So I always was like an employee with a salary, with benefits, and so on. And I think when I wrote my first book, I felt kind of an appetite to write, and I felt like it's something that can also provide be as a source of revenue on its own. So after I published my newest book on language models, I told to myself, like, it could become a series, and if it becomes a series, people will expect at least one book a year at least. Maybe if I manage more. So for this, I needed time, and I decided that the only way to use time without ruining your health is to resign and get this 40 hours a week that usually I spend doing my job. Yeah, and my children, they are already 17 and 18. They started college, and in Canada, it's not as expensive as it would be, for example, in the US. So I told to myself, like, if there is there is never the best moment to make such decisions. But if it existed in some universe, this would be this moment. So yeah, I will. So my plans are to write at least 3 books on new topics: reinforcement learning, computer vision, and diffusion models. And also, I want to refresh the first book that I published already 6 years ago. So probably for some readers, when they see that the book on AI is 6 years old, some might think that okay, it's outdated, even if it's not. But there is always something you can improve. I want to add more code, so make it a little bit more hands-on. So yeah, these are my plans for the next 2-3 years.
Nice. So, like you say, it was a kind of a now or never decision, and it's kind of a chance for you to go out and, kind of throw yourself into it. And, obviously you've built a decent following up through your books and from your social profile and stuff and your newsletter. So I guess, as you say, it's kind of the right time. But I don't know if it's the same in kind of data science circles, but something that you see, for example, in product circles, tech circles in general, is this idea that, like, okay, yeah, sure, it's the kind of whole sort of teachers are the ones that can't do it. They're the ones that teach, right? And like, you've obviously been super hands-on, like you say, for the last sort of 20 years, actually doing this stuff for a day job. And now you're going to be kind of researching and building books up and kind of building content. And some people might sit there and say, oh, yeah, that's the kind of thing that, talking heads do. They can't hack it in a real job. Maybe they're just grifting away. Are you worried about kind of stepping away from being a practitioner and being seen as more of a talking head?
Mm, no, because well, first of all, I don't think that I can not to work at all. Okay, so I cannot be just full-time writer and just be in my bubble and never take a step away. So I will most likely find some kind of advisory positions to the companies who need access to an AI expertise, but at the same time, probably they are not ready yet to hire someone full time, because this kind of expertise currently is very expensive. And I will feel it when when I will receive my wage. But yeah, so I think that I would be open to maybe work with 2-3 companies and of different kind of directions. For example, one more kind of working in some specific industry, one maybe more general AI, some kind of platform for AI, and something in between. So I want to of course, stay updated. But also, when you work on the books of the kind that I write, and especially with if you look at my recent one, it's a lot of code inside. So I code it myself. So I just don't write like, okay, this is how it might be. I actually code, and I put the code online, and I say like, you can do it yourself. You can see that it actually works. So in my language models book, I present a kind of the evolution of the language models from early count based to the latest transformer based, and you code all of these kind of steps in the evolution yourself. So no, I don't think that I will be entirely a talking head, and I wouldn't be happy being this, to be honest.
Now, I think that there are certainly companies out there that you could work with, and maybe, given that you've been talking about this stuff, like maybe you should go and try and pitch to OpenAI or something like that and go and try and help them out. What do you think about that?
Oh well, after everything they over promise it and under deliver it. I wouldn't feel how to say, it wouldn't be honest after all the critique that I wrote about them to join them. So, and the biggest thing that is a turn off for me, it's this open prefix in their name. So like it's my opinion, but you don't start a company with the goal of democratizing access to AI and then end up selling APIs for $200 a month, or I don't know how much they will charge, try to charge later. So like it's a totally opposite of what the company was built for. And many people who left, they OpenAI, they left for this reason. So this transformation was unexpected by anyone. So and no one really understand why they still keep this open prefix in the name.
Well, you seem to be just like the kind of man that could go in and be the new sheriff and go and sort that out. But I understand, the ethical dilemma you have there. So, maybe not yet. But let's talk about your book. So you recently released the 100-page language models book. We just kind of discussed how it doesn't have exactly 100 pages. Oh, there you go. I've only got the ebook, so I couldn't put it on my shelf behind me. But maybe one day. But the book obviously kind of has a very descriptive name. And I know what all of the words mean in that sentence, but just to be very specific in your own words, what is the core value proposition of the book? And I guess also, who's it written for?
Well, every time people ask me like who is my target audience, I answer it's myself 10 years ago. Well, for language models, probably it's not 10 years ago. It would be more like 5 years ago. But like it's a starting point that leaves you with the least number of questions after you finish reading it, because currently, books on any material on AI is mostly very superficial. So they talk about what an LLM can do. They can even mention that it predicts the next word, but they don't really explain why. What's inside this LLM that makes it predict the next word, and every time it predicts the next word, it ends up with a readable sentence that makes sense. So why would it be the case? And if it's already knows the sense, why wouldn't it just output all the words at the same time? Like if you already kind of know what you want to write, right? So in my book, I explain actually the mechanics of how information flows in the neural network, and not only in the neural network, because language model existed way before transformers. Before transformers, we trained recurrent neural networks, and they performed very well. Well, not as well as transformer perform today, but currently there are modifications or adaptations of recurrent neural networks that just as good as transformers. So like if you want to start, like you start from scratch, but you after you read it, you want to feel like, okay, now I understand everything they talked about, because otherwise I just had to trust their word, because I wasn't aware of the inside what's going on. So if you want to feel this feeling, and I think that this is a very liberating feeling, you read my book. And also in these books there is a lot of hands-on. So some people skip it because, well, they don't need to program to feel confident, but some really like they don't trust, they don't trust the word. I don't take your word for it. So they run the code and they actually see how the model starts from generating garbage, eventually starts generating better and better quality outputs, and then you see, oh wow, okay, this is how it happens. So basically you can feel in the end that you actually can train ChatGPT. If you had enough money for this many GPUs, you would be able to do it.
Well, I mean, that's a bold claim. I definitely want to come back to some of those points, especially around the kind of like watching it get better as well, because that's something that I've seen kind of earlier in my career with the pre-LLM stuff as well. And it's definitely kind of almost a magical evolutionary thing that seems to be happening. But just sort of sticking with the book for a second, I remember many, many years ago, quite old, that the great scientist Stephen Hawking, when he wrote The Brief History of Time, said, I believe, something along the lines of that every equation that he puts in a book would halve the number of sales for the book. And in the end, I think he put in like one because he couldn't avoid it. Now, you've got a lot more than one equation in your book, as well as all the code as well. So do you think then, I mean, I know you said that potentially maybe some people could skip stuff if they didn't need to kind of do the code, for example, but do you think that having the kind of let's call it hard statistics and stuff in there, and the hard math, do you think that puts it out of the reach of kind of standard everyday consumers, or maybe like product people like me? Or is there enough context around the equations, in your opinion, for them to still get some kind of value out of the book?
Well, this is what I heard too. And when I wrote my first one, and people started to, even before I published it, people, because I put the chapters online, people started to give me the same advice. Like if you should choose, you should either put equations in the book or you don't, and it will be a totally different people who will read the book. But I think that in AI, and especially in the kind of AI that LLMs are, there is not much math that well, I would say there are none. There is no math that would be hard for a person with a higher education to read. Okay, so the only thing that you should become familiar before you read the book is the first derivative of a function. And like if you went to college, it's probably the first thing that they teach you in calculus. So the function can grow, and the first derivative show whether the function in this point goes up or goes down. So, like, first of all, it's very a simple concept, and second, it's explained in the book and with examples and so on. So once you get just this piece, the rest of it, it's like, yeah, I know that people sometimes are afraid of equations, not because they think that equations, they know that these equations is hard. It's more like they are not sure how to read it. Okay, so like this, for example, sigma notation, like summation or I don't know, the first derivative and so on. So when the person looks for the first time at this equation, and the first thing is like, how do I start reading it? Okay, so where do I start from? How to get the meaning of it? It's not like, okay, no, the meaning is too complicated for me. No, it's more like I just don't know how. So if you explain in your book, like, this equation means exactly this. So this part is for this, and this part is for this. You explain it verbally. You give a couple of illustrations, and the person starts feeling more confident. And I received a lot of feedback from people who said, previously I opened the book, saw a formula, closed the book, but this time I decided to try to get it. And actually, I feel proud of myself that I understood most of it. And also there is this online version of the book where people can comment, other people can answer. So I sometimes answer things that are unclear. But again, if the things are unclear, I can fix the book. And because I self-publish, so if I really find some serious problem with understanding, I can tweak a little bit so that it's simpler.
I guess they could also potentially just sort of take photograph of the bit of the equation and stick that into ChatGPT and get it to explain it to them if they needed to, right? Because that's the sort of thing that you could use as a use case.
Crazily effective thing, because previously the problem with the textbooks was that the textbooks were written for students, and students usually have access to a professor. So if the student reads something and they don't get it, they can talk to their friends who probably got this. Or if no one of their friends got it, they go to see a professor. The professor says, okay, well, here we do summation by this variable. Why? Because. And then we take an average. Why? Because. But now, as you say, like, you don't have access to a professor, you don't have any math savvy friends. You take a screenshot, you ask ChatGPT or whatever your preferred model is. Of course, there are chances that the answer will be kind of wrong. But again, the level of math and the information that I talk about in the book, it's not, something like cutting edge that no one ever discussed online. So something like this would already be in the training data of this LLM. So for it will not be something new. So it will just repeat what it read in the documents it was trained on.
Fair enough. Well, hopefully some people can do that. But one of the things that you do say in the book is that it kind of helps to make AI more accessible. Now, again, obviously notwithstanding the equations that we just discussed. But it kind of feels like these days everyone and their dog is claiming to be some kind of AI expert and, not always being able to back that up. And I know that you talk about that a lot on LinkedIn. We'll talk about the hype in a minute. But do you really think that we need to make AI more accessible and give people even more opportunities to kind of, pretend that they know things because they read half of your book? Or do you think that the benefits outweigh the potential grift that could come off the back of it from people that have read it?
Well, I think there are two kinds of people. There are people who can think algorithmically, and there are people who can. Okay, and it's very hard to make a person who cannot think algorithmically to start thinking algorithmically. Maybe if they dedicate a lot of time and have a good teacher that explains really for them that a lot of things that are going on, especially in technology, is not like some wishful thinking and things appear. There are algorithms behind this. So if the persons, and I don't say that people who cannot think algorithmically somehow worse than others. It's just that they are better in something else. There is emotional intelligence. There is just empathy, and people who can think algorithmically, maybe good scientists, but have no empathy at all, or very limited one. So we are all different. But if you can think algorithmically, I think that AI uh, allows you to start applying this algorithmic thinking much easier, which is much smaller entrance threshold compared to what it was before. For example, when I started to code for online, like create websites and so on, I I didn't know Perl, and I didn't know PHP, and PHP at the time was less popular than it is today. But Perl was everywhere. I didn't
Oh, yeah.
know it. I had zero books on this, and internet. It wasn't like today. You go online, you download a book about Perl, you read it, or you ask questions about Perl, and you have answers. So I opened someone else's code with Perl. I looked in it, and for me, it was a total, it's just a combination of symbols that I kind of try to guess what it means, but I never sure. So I learned to code in Perl by trial and error. So imagine how much time it took for me to code my first transactional website with this. So today, if the person is not familiar with web development, but they need a website, they can just think algorithmically. So, okay, I want when I click at this button, I want this image to change to that image. So write me the code that does it. So the person will much faster advance to to where they want to be compared to before. And like before, for example, if I want to create an application, there is backend, there is front end, there is database, there is networking, security, and so on. Imagine how much should I learn upfront before I actually start building something. And today you can make an abstraction. You can say, well, okay, I don't understand right now how React works, but I know that React is a popular web framework. So I will use it. I will ask an LLM to use React and create this kind of UI for me. And then when I will have time and I will think that this is actually critical for me to understand, I will read more about React, and I will become more familiar. And also, you will learn by example. So you ask an LLM to generate something, you read the code, and you kind of start getting a feeling. Okay, my words were translated in this code, so I think that this part reflects this part of my word, and this part reflects this part of my word. So it's a much faster learning. And you can also ask questions like, why did you use this command? I couldn't ask this question about Perl to anyone, but now you just say like, what exactly this combination of character means? Explain me like character by character or command by command. No, so I think that it's a great tool in the hands of a person who was kind of built for using this tool. But if you aren't algorithmically thinking person and you try to use AI, I think it will be more a disaster, and you will end up frustrated. But I think like in anything in life, people try. For some it sticks, for some it doesn't stick. But in the end, if it sticks, at least for one more person, we can say that it's a success, because previously this person was afraid of touching anything computer, and now they are.
No, fair enough. Well, like I said, everyone's claiming to be an AI expert these days, but again, not everyone really is, and there's a lot of fluff out there. So just for the record, I want you to just define, almost in a quick lightning round, to sort of define a few terms as simply and succinctly as you can so that everyone's on the same page for the rest of what we're going to be talking about tonight. So the first thing that I'm going to ask you to define, and I know you have opinions about this phrase, and like whether it actually is like a marketing phrase or an actual phrase, but the first phrase is machine learning. How would you define that as quickly and succinctly as possible?
Well, machine learning is programming a computer without coding. So you give examples and you expect the machine to learn what to do based on the examples that you have shown.
So next up, I want you to define artificial intelligence.
Artificial intelligence is just a term scientists invented to understand one another. So it's anything in science that leads to a machine doing some work, usually only people were considered to be capable of. So from this definition, a calculator is AI. Because previously only humans can count and multiply numbers and divide numbers, and now after the invention of the calculator, a machine can do it. It's just that we are so used to this, so we are no longer consider calculators as a branch of science. But initially, the machines weren't capable of doing this, and everyone dreamed about a machine being able to add the large numbers. So it was a kind of a direction of science, engineering, and so on. At the time, it was AI, not today.
All right. So thinking then of invented terms, I'm going to go one step up for you and ask you to describe in as simple a way as possible AGI, or artificial general intelligence.
Well, this is a branch of science fiction that says that a computer at some point be can be as capable intellectually as a human being, or more capable. There is no definition in the real science that we currently have of what AGI is. So there is scientific fiction books where AGI existed, and people, for example, this HAL or HAL 9000. So currently, people use the term AGI, and everyone has their own understanding of what it is. Some might say that ChatGPT is already AGI because it's smarter than some people. But again, it's very I doubt that it's smarter than some people in everything. Okay, so some people will still be able to, to cook a breakfast and it will be eatable. But if you ask a machine to cook it for you, mostly you have high chances to be poisoned. So you cannot trust LLM currently, like they say, for example. You can have LLM-based agents, and we might probably talk about agents later. But yeah, I would say that AGI is a machine to which you can trust as you would trust a human being. And currently, we don't have any such machine.
I don't know, like you say, I think there are probably some people that I trust less than ChatGPT, but that's more of a personal problem, I guess. But yeah, you said then, but obviously AI agents and large language models. So they were actually going to be my final two things to define. So I guess let's do large language model first, because hopefully that'll be a quick and easy one. And then we can go on to AI agents and what you think about those. So how would you define specifically and simply a large language model?
Well, first of all, large today is already the term that is not the same, doesn't have the same meaning as it was last year or 2 years ago. So a large language model is a language model with a large number of parameters, and because of this large number of parameters, some abilities of earlier models that earlier models couldn't exhibit, now this large language model can. So what are these abilities? These abilities is to maintain a conversation. So the models before large they couldn't maintain a conversation. You could at best use them as one shot. For example, you give it a sentence to translate and it gives you a translation, but you cannot follow up and say, why did you translate this word like this? For it will be too complex as a context. So large came with the capability of supporting larger context. So the conversation can be multi-turn, and you will have a feeling that the model actually follows all previous turns of the conversation to answer your more recent question. But again, you only have this feeling. So it's just that, like as a human being, we are easily fooled. Like there are magicians, that they do some tricks with hands, and you don't know. Oh wow, why the coin was in this hand and now in that hand? So the large language models are very good magicians in this sense. So they generate answers that look very much like if they understood, even if it wasn't the case. So yeah, so the large today is, I heard something around like 20. The model that has more than 20 billion parameters is considered large, but 2 years ago it was 7. So this is why, for example, in my book, I don't say this is the 100-page large language models book. I call it just language models book, because I know that if I say large, people will say, well, what do you mean by large? Because like in the book, you talk about the models of 1, 2, 3 billion parameters. Now it's considered ridiculously small. So I told to myself that probably this year, maybe next year, people will stop saying large. They will just say language models. Like, for example, big data. It was big in 2010. Now it's just data. No one says I have big data or deep learning. Okay, well, we still use this term, but again, deep learning. Why it was deep? Because before some techniques for neural networks were invented, a neural network could have only one layer between input and output. If you add more than one, it didn't learn. So when this new technique for have been invented in 2009, 2008, scientists were managed to train models with two layers between input output, then three. Today we can have hundreds. So no one says, like, what is the point of saying deep learning if all networks we train are deep now? So it's just a word that you add without any meaning.
But it's interesting, before we go to agents, like there's a couple of points there that I think are really interesting. First of all, and this is something that happens in your book as well, like you say, you kind of start from small language models, I guess, or like, you kind of go back to basics to some extent, and then you start to build up, and then you eventually get to more of the kind of LLM side of things. Is it, and forgive me for being a bit of a, not a data scientist. I think I got like 28% in a statistics paper once, what were the chances of that? But is it really just the case then that we've kind of taken and built upon existing or pre-existing stuff that was smaller and therefore didn't feel as capable, and we just added as much compute and data to it as possible, that eventually it started to look like it was doing something much more clever and magical, when actually it's almost just like a natural kind of aspect of the fact that you've added so much sort of power to it?
Well, yes, in one sense, but it wouldn't. So yeah, so it's all about the size and the amount of data that we use. So you see, the progress in language models, intelligence, if you want. It slows down, like, because companies can no longer get more data, so they try to train larger and larger models, and you can see OpenAI's 4.5. So they talked about GPT-5 for 2 years, and in the end they released it 4.5. Why? Because it was already their largest model, according to what they told the public. So this largest model, like in history, it's not better than smaller size models that came after it from other providers. And So yes, it's data and it's size, but it wouldn't be possible without this paper that probably everyone knows.
The
Attention is all.
Google one.
Yeah, the Google paper. So basically, what was revolutionary in this paper is that before this paper, as I said, the most popular architecture of neural network for language modeling was recurrent neural network. So in recurrent neural network, you have a notion of kind of a notion of state. So the neural network reads one word, it puts this one word in the state. We can call it like some kind of equivalent of internal memory. And then when it reads the second word, it can process the second word conditioning on what's in its memory. So if, for example, the recurrent neural network read, let's say, the sentence, then to process the next word, or the first word of the next sentence, it can process it depending on what the content of the first sentence was. And logically, it make a lot of sense to do the processing this way. The problem with this approach is that you cannot train such networks on very large clusters of GPUs, because to process a sequence of words, you need to process them one word at a time. So you read one word, you update the state, you read the second word, you update the state. So it was sequential. So scientists could train in this sequential way some sizes of models, but then after some specific size, it all became very slow. So you cannot really put more data in it, because it will take 100 years to process it. So what transformers changed fundamentally, they removed this sequential dependency. So basically, transformers can read the entire 100,000 words in one shot and process them all in parallel. So you can split your input into multiple pieces, put them into different GPUs, process each piece in parallel, then combine the results and proceed this way. So this ability to be kind of indefinitely parallelizable, this is what resulted in such huge models as like 100,000, 100 billion parameters, even trillion parameters, because it doesn't matter. If you have enough GPUs, you just chunk your model and your input into smaller chunks that fit into each individual GPU. You run the processing in parallel. So this scales in large data centers very well. So this was kind of the kind of liberation of the model. So from this sequential dependency.
And Nvidia's stock price keeps going up as you keep talking, so that's a good thing for them as well. But the other thing that you kind of talking about as you were describing LLMs was this idea, and I think you've said it a couple of times so far as well, is this idea that they're predicting things, of course, based on the model and the weights and all of the things, that the stuff that I don't understand fully about, the kind of internal mechanics of how this is working all the stuff out. But they don't really know anything. Do you think that there's any chance at all, because some people do, that there's any chance at all that there's some kind of consciousness in there somewhere? Or is it all literally just good mathematics and scale?
If you read my book, okay, it's not an advertisement, it's just an example. So if you read my book, you will see that the model of the ChatGPT kind, and in the equation y is equal ax plus b, they are not mathematically different from one another. Okay, so they are mathematically equivalent. So basically, if you think that y equal ax plus b can become conscious, then you can believe that a larger version of it can also be conscious. So why I say it this way is because um, like it's 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 the core of machine learning. So the core of machine learning is what? Is that you first choose the structure for your equation. So and for example, you choose the structure y equal ax plus b. So what you have is you have y, it's your prediction, and you have x is your input. We call it the training data. And then you want from y and x, you want to deduce what would be the a and b such that when you put all your training examples as input to this equation, you get the output that is similar to what you have in your training data. So if you give a lot of examples that make sense, eventually the algorithm will find the best value for A, the best value for B. It's exactly the same what happens with language models. The only difference is that instead of having just A and B, you have millions of such A's and B's, but they are all combined in a very, very simple way. So if you a little bit familiar with machine learning, you know that when you train any model, it will only be it will only have good level of performance when your data that you feed it uh, like in production is similar to the data that you use it to train it. Okay, so it's called it that it's only effective in distribution example. So if you let's say a very simple example, let's say you train an image classifier, so it should look at the image and say whether it's a dog or a cat or a person or a house. So if, for example, you downloaded from the internet a lot of pictures and even someone labeled them, then you train your model and let's say it makes only 2% errors. So you are happy, you have a perfect model. Then let's say you have a social network like Instagram and you use your model and you want the model to assign different labels automatically to your Instagram images. And you start testing it and you see that it doesn't work as well as it worked when you trained it. And you ask yourself, like, why? And the reason would be that you trained your model on examples from all over the web. But Instagram has a very specific filters that people apply to the pictures. They have a specific currently, I think you can put everything, but in the past it was only squared and so on. So all this is new. It's new to your model. So if in your training data there were very few or none of examples of the kind that you will see on Instagram, your model will be poor in this specific scenario. So it's the same about LLMs. If you ask it a question that was answered somewhere in the past in some document that was used to train it, it will repeat. I don't say that it will repeat it word by word, but it will repeat it from the kind of semantic perspective. It will even be able to correlate. Maybe to answer your question, you need two parts. And one part of the answer was in one document, and another part was in another document. And the model is large enough to be able to kind of say, okay, I need this and I did this. When I combine it, this will give the answer. But if your question is a little bit outside of what the training data contain, and maybe to answer it, the model needs two parts, but only one part was in the training data. The other part wasn't. So the model will still try to find the closest possible document for this second part, and this is what we call hallucination. So for it will just try to kind of approximate the best it can to answer your question. And sometimes you ask about tomato, it answer about a cucumber, and you don't know whether you should trust it or not. This is why they say you should always, verify independently everything that an LLM says. So, like fundamentally, it's no different from this image classifier. It's just, as I said, like it fools you into thinking that it's more intelligent, but on the behind the scenes, it's the same math.
Yeah, it reminds me of a few years ago when I was playing around with Word2Vec, which, almost feels silly now given all of the new stuff that's come out since. And, like the classic example of Word2Vec was, king minus man plus woman gives you queen. And like you look at that as someone like that looks at that for the first time, you're like, that's magic. And, obviously it's not magic, but when you train the models and exactly as you say, like you train it on a few documents or whatever, and obviously as you've kind of touched on before, the results are kind of garbage, right? But the more data you feed it, the more it starts to do some of those things. And again, for me, the first time I saw it, just mathematically manipulating words to get different words that's made semantic sense, and my mind was properly blown. And again, that's a relatively simple example in this new world. Or I guess that's a question of, is it a simple example? Or is that more complicated than I'm giving it credit for? Or are LLMs not as complicated as I give them credit for?
Well, this example of math on words with king and queen and woman and man, it's like I use it in the book to illustrate the idea that once we, because the algorithm that allowed us to discover this property is called word to vec. By the way, Tomasz Mikolov, who invented the algorithm, he wrote a foreword for my book, and I was really proud about it. So yes, so once we have seen for the first time that you can do math on words, it was almost guaranteed that models like ChatGPT would be invented soon. Well, soon in the it might take 3 years, maybe 30 years, but it's inevitable because when you see that you can manipulate words as simple math, of course, a deeper neural network can find more nuanced ways of combining these what we call embeddings to obtain some more complex relationships between words. But before this result, um, not all scientists were convinced that our language has a algebraic interpretation, and maybe it doesn't have this algebraic interpretation perfectly, but it looks like it might be 95, 97%. Like all you can write in words, you can also write in math, and the equivalence will be almost identical. Of course, language is ambiguous. There are words that in some contexts mean one thing, in other contexts mean a different thing. But again, if your model is large enough and for all possible contexts, it has a specific set of parameters responsible specifically for this context, eventually it will be able to talk about anything. But again, only when the the topic of the discussion is within the training data distribution. So you can try it yourself. For example, we don't have currently a cold fusion stable cold fusion reactor. And one important reasons why we don't have it is because to make this reaction happen, we need it happen inside a bubble of plasma, so that those particles cannot escape it. So to create this bubble of plasma, we need algorithms that control this plasma, and they keep it in a stable state. But currently, I think the best we can do it's fraction of second that this plasma is stable, and then it blows up. So you can go to an LLM and say, "Oh, I have this cold fusion reactor, but I need an algorithm that will control plasma perfectly." And you can put all the parameters of your reactor in it. I give you 100% guarantee. It will tell you something like, "Well, I'm still limited. I'm still learning. Sometimes I can." Well, if you can answer any question, answer me my simple question: How do I control plasma in my reactor? And it can't, because there is nothing in its training data that would support this answer. So people who imagine that an LLM is something bigger, that LLM can imagine something new, can be creative, they cannot just imagine how large the training data set that was used to train it is. Like when I tell you a billion documents, you have hard time telling the difference between a billion and a million. And then I tell you, what if it's a trillion? Okay, so like it's a lot. So people often test LLMs by they know something. Oh, okay, I will ask it. We'll see if it knows it too. And yes, it knows it too. So the person eventually will see, oh my God, it knows this, it knows that. But it's just because your knowledge is so unoriginal that of course it knows it, because it was already in some documents written by others.
Well, again, some people know more things than others, right? But yeah, I take the point, and I think that there's nothing more sobering than asking an LLM to answer maybe maybe more of a niche topic that maybe does have documents, but maybe not so many. And I just a stupid example. I remember asking it to kind of give me a description of all the monsters in Doom, classic Doom, and it started inventing monsters for me. It was really cool, but at the same time, didn't exist. And like you sit there, and you think, well, obviously, if I'd never played the game, then I might have believed that. And then you think, well, okay, fine. Now let's move that on to something that I don't know about. And then what am I supposed to do with that? And how am I supposed to even know? So yeah, it's a really interesting kind of point, this idea that like the people, and this is something that I've kind of said to in presentations before, the people that get the most benefit out of these things, or seem to get the most benefits out of these things, are the ones that can kind of do the work already, and it's going to help them do it faster or help to sort of, you know, accelerate certain areas or thinking. But if they're using it as some kind of replacement brain, then they might not end up with the best results. Is that fair to say?
Well, this is one of the. It's not my invention. I read it somewhere, but I like to post it either as a comment or as a post. Like, if you want to be impressed by LLM's intelligence, ask it about something and you don't know anything about. Okay, so like it describes perfectly what people do. Okay, they ask something and they receive an answer, but they cannot really judge whether the answer is accurate. And you only see it when you actually try to write something reliable about some topic. And like, for example, I was writing a book about LLMs. You think I'm stupid and I didn't try to cheat and ask ChatGPT to explain some concepts and just take it and say, oh wow, cool, I will put it in my book. It didn't work this way. Like, because I know how this thing works. I just want probably to see how better to explain this. So I ask an LLM, like, explain this thing to me. And when it explains, I see that there is a mistake here and a mistake here and a mistake here. And what's the worst is that previous models, like before this current new wave of what we call reasoning models, like previous pre-reasoning models, basically you tell them this is a mistake, and usually it answered like, oh yeah, really, this is a mistake. And you could even point to something accurate and say it's a mistake, and it would say, yeah, I'm sorry about it, and it would tell you a totally opposite thing. So like, even if you suspect that it's a mistake and you say, are you sure about it, it will change its answer. And you don't know, like, you just ask it, are you sure? You didn't imply that it's an error. I just want to know whether you are sure. And it just gave it an opposite answer. But now it's even worse with this reasoning model. I don't know why this effect happens. But now they double down on lies. So the model explains to you something. You see that it's wrong. You say, no, this part is wrong. But the model will say, no, it's not wrong. And it will continue to kind of still try to convince you that total nonsense is not a total nonsense. So now, like, it's an opposite. Previously, you could at least make it doubt, but now it doesn't doubt. It just doubles down on the lies. So yeah, so I think that you are right. So if you know something, if it's your domain, for example, if you are a good software engineer, the code that LLM will write, and you look at it, you might say, "Oh, cool," and you continue, because you already know what you would write. So if it correlates with what you would write, it's a huge time saver. Like, you don't need to type all these keys. It's all generated automatically. But if you just accept anything without questioning, without double checking, eventually it will start with some small lie, then it will be bigger lie, then it will become a huge lie. The same about code. It will start with something that works, more or less, then it will work worse and worse and worse. And eventually your code base will be so huge that everything it will add will just make the situation worse. So this is why some people say that between now and, let's say, in 2 years, the amount of technical debt that will be generated will be so crazy that in 2-3 years there will be companies whose specialization will be to fix what LLMs generated by for people who don't question anything.
Well, that's all the engineers getting hired back to another company at that point after they all get apparently laid off. But do you think that's a solvable problem? Like, given what you know about obviously the architecture, the way these things work, the potential, like, whatever, new data or new compute, maybe new techniques that they can bring in to try and refine and improve this. Like, I know there's things like RAGs, for example, which you can use to kind of try and ground things in a bit more truth, for example. But is the concept of like this stuff getting better enough that some of the things you just talked about start to go away? Like, is that a realistic hope, or is it kind of baked into what these things do and how they work?
Well, there are some domains where I personally remain optimistic, but again, I'm optimistic, but I'm not, fully convinced that it will work. So you heard about this recent wave of interest for reinforcement learning, and my next book will be about it for this reason, because reinforcement learning allowed for the first time, I think, in history, I might say, to train a machine to generate something by itself. Okay, and if this something is good, then the machine learns. If it's not good, the machine learns not to generate it. And why it's important? Because previously, for example, for the machine for the LLM to be able to give you an answer, you train it to predict the next word. And so basically, the information that you could put in this LLM, if I can say, brain, was only limited to these sequences you used for training. But now with reinforcement learning, the approach is different. You only have the task and you have the solution, but you don't have the the sequence of steps that bring that start with the task and ends up with the solution. So this requires from the model to generate something that if it brings to the solution, then you give it the reward of, let's say, 1. And if it doesn't bring to the solution or doesn't lead to the solution, you give it the reward of 0. So it's much simpler to generate this kind of training data than to generate the training data with a solution for all possible problems, right? So but again, why I say I'm optimistic is because, for example, let's say you take the coding. Previously, you could just use one code base once for training. You just show it to the model. You say predict this token when you see this prefix. You predict this token when you see this prefix. So you run it once, and that's it. But now with reinforcement learning, what you can do, you take one repository from GitHub, for example, and you randomly hide one function in it or one class, and you ask an LLM to verbally describe what this function does without coding, just verbally. Or the input is this, and then it's multiplied by that, and then the output will be this. So the LLM will write the verbal definition, description of what the hidden function should do, and then you use reinforcement learning so you show the entire repository to the model except for the hidden part, and then you say generate the hidden function based on this verbal description, but you don't show how. The model should figure it out on its own. And if after the model generated some function, you can compile this code or build some application, and it runs and all the tests pass, you say it's success. You give it 1. If it fails or tests don't pass, some tests don't pass, you give it 0. So the question now is, so the model generated this function on its own. Is it something new? So the model really, randomly tried this and that to eventually succeed, or it just used some solution from some other repository that solved a similar problem. So like you don't know it for sure. And I think that for the model, the simplest approach would be to actually reuse some solutions existing
Yep.
elsewhere. So like if we could exclude all possible contamination, like from our training data, so if we hide this function, so nowhere else in the training data it exists, this might indeed make the model much smarter, because eventually it will try to, to generate new stuff in order to get this high reward. But for now, it seems to me that the model will use shortcuts and just deal with something it already knows. So yes, to some extent, the model can learn some new tricks, but whether it will significantly expand the this in distribution, the range of those in distribution examples, it's remaining to be seen. But so far, we see a lot of progress in the most in the newest models that released, like Google released Gemini 2.5 Pro, Grok, and others. They're all much stronger now in math, in reasoning, in logic. It's because of this more easily available data that you can reuse multiple times. Whether, as I said, like there will be probably some limit. For now, it seems to go quite high. We will see how high it can go.
Well, fingers crossed. Okay, the last thing that we're going to get to then, and given that we've just kind of described some fairly unreliable models that they look kind of good and they can definitely have some decent use cases, but at the same time they can't 100% be trusted based on what we described earlier. Now we're talking in the second half of 2025, or maybe even the first half. It's all about AI agents now. Like, that's the new thing. Agentic AI is the future. It's going to revolutionize everything. We're going to be able to automate everything. These autonomous things are going to go off and they're going to do all of our stuff for us. Some people are even saying that they're going to remove entire professions because we won't need any of the people to do that stuff anymore because these things are going to be so good. What do you think about all of that? And indeed, to some extent, before I guess you say what you think about that, like, what's your brief summary of what an agent even is?
Well, my PhD in 2010 that I defended in 2010 to 2010. My PhD was in multi-agent systems, and so for me, reinforcement learning and agents, it's not some new stuff. So scientists actually worked on it very intensively in the 2000s. If you open the book, like the Artificial Intelligence, A Modern Approach, this is the textbook number one in all schools across, especially in North America, but in Europe, I think too, from Russell and Norvig. So the chapter 2 is called agents. So if you look at the definition of an agent, so an agent is an entity that lives in some environment, and this entity can execute some actions, receive some feedback from the environment, for example, in forms of some observations about the environment, or even rewards if you want to work with reinforcement learning settings. But the agent, to be called an agent, should have agency. So what does it mean? It means that it should have its own goals, okay? So its own motivations, what it wants to achieve in this environment, okay? And it should be capable of planning what to do. So if you take this, this environment and the definition and this agency definition, and then what do they call agents today? What they call agents today, it's a language model that you instructed to do something. Okay, so you might say you are a helpful assistant, and you receive a document, and you must answer a question that I ask about this document. So, like, I just described how people use an LLM, but now it's an agent. So, so you basically you proclaim that for this specific use case, this generic language model is now an agent. But the problem is, just because you proclaimed it an agent, it doesn't make it agentic. So it doesn't add its own agency. It doesn't have any goals. It doesn't have, it doesn't plan. And even if you tell your goal is ABC, there is nothing in the LLM itself that would guarantee that the model will always do everything to achieve this goal. Why? Because, well, we already discussed. Because if the LLM is confronted to a problem that looks very much like the training data, it might feel more or less confident and do what you want. If there is any small deviation, it will start hallucinating. And in the case of hallucinating by just talking to you, it's one thing. But when it hallucinates, when it executes some actions, this leads to potentially disastrous consequences. And there is no way to, you know, to optimize the LLM to become better with time, except for reinforcement learning that potentially can provide this, continuous improvement feedback loop. But currently, this is not the reality. It's more science fiction that you can instruct an LLM with some goal, and I'll explain it what kind of tools you can use, and then when it uses those tools to achieve those goals, it receives such a strong signal from the environment that it will update itself. And after maybe, I don't know, 7, 10, 25 trial and errors, it will suddenly become better. No, you will need, according to the current science and technology, you will need hundreds of thousands of examples so that the model will eventually learn to become a little bit better. This is what they do with coding, for example. It's not one function that that you hide to provide the reward. You hide hundreds of them. You hide thousands of them. You use hundreds of thousands, even millions of code repositories, so that you can beat this benchmark by a small margin. So it's the same about this agent. So just because you proclaim them agents, they didn't get this agency on their own. So even if you say, okay, this is your task, now repeat it to me so that I understand so I'm sure that you understood. Even if it repeated it to you, there is zero guarantee that it actually mean it, because as I said, it's not talking to you. It simulates the sequence of words that make you feel like you are being talked to, but it doesn't. It just generate. It was trained to simulate this sequence of word based on the training data that was given to it. So no agency was implanted in it somehow, and no one really, to be honest, knows how to implant this agency in AI. If we knew it, this would probably lead us to this AGI. But so far, no one has an idea what it should look like. So yes, there are agents. People call them agent. They are not agent, but sometimes they probably might solve some problems. And when they fail, it's not a catastrophe. But most of the time, if you see the applications of these agents that they talk about online, most of the time it's okay. Read this document, maybe make a search, download that search result, read it too. So like they still remain in their in distribution, because they were trained on the web data, and you test them on the web data. Yes, some results may be good, but if you take this agent and you put it on your intranet in your organization, and you have this legacy tool, that Oracle tool, you have this tool that only works in Internet Explorer 6, and you tell it like, now figure it all out. I want you to learn everything and talk to me. Well, this will never happen. So it's a wishful thinking.
Well, maybe that could be one of your future books once you get the next ones out of the way. But people might listen to this then, and all of the stuff that we've been talking about tonight. And, obviously you're someone that has deep experience in how this stuff works. You've written literally a book on how to build LLMs, well, language models and large language models. You know the space. You're also very outspoken online. It's very clear that you want to help people see through the hype. Like you're always very keen to kind of, when there's news or someone's making a claim, to try and puncture that claim. And you might have people thinking that maybe you're kind of a little bit on the like the bearish side when it comes to sort of generative AI, LLMs in particular. So, you've got the big booster hypers on one side, and you've got the kind of the deniers on the other side that think that it's all of it's hype and that none of it's going to work and it's all going to collapse. Now, I'm not going to assume that you're on either end of that scale. And like you say yourself, you do use LLMs, but like, where do you put yourself on that scale? Are you like squat in the middle, or are you more on the booster side, or are you more on the kind of the skeptic side?
Well, first of all, when I criticize something, and people often think I criticize the technology. I never criticize the technology. The technology is just a tool. Okay, you have a hammer. What is the point of criticizing hammer that it doesn't help you in playing the piano? Okay, well it wasn't built for this. So when people actually start talking about, okay, I play piano with a hammer and everyone should learn it, I laughed about it because this is crazy. So when people say that, okay, now with an LLM you can do this and you can do that, and it will in next year it will replace software engineer, and then it will replace product manager, and then it will replace everyone else. I ask the question, where do you draw this prediction based on what? Are you a scientist? Did you actually do you actually have an understanding of how exactly the model is trained? What exactly the limitations? So when people make such bold prediction not based on anything, I laughed about them, but I don't laugh about the technology. The technology is awesome. Okay, probably if you ask me, probably it's the most impressive for me as a technology since I don't know what to compare to, either the first smartphone or even the first computer. Okay, I mean the first personal computer, because it gives you the, as we discussed in the beginning of this conversation, it gives people way into using their brain such that it provides a result, a useful result. Because previously everything would stay in their brain. You cannot really, communicate your thoughts into computer and make. And if you are not the programmer, if you don't know how the databases work, you don't know anything about web development. Previously, you felt like you are the person with limited how they call them people who physically limited. Okay, so you
Hmm.
don't have hands. Okay, imagine you don't have hands, so you must code with your nose. But now you actually can instruct a computer to do what you want, and this is liberating for many technical people who just don't have some knowledge which takes years to acquire. So like if people start saying like it will replace people, I laugh, because I give a simple example. Currently, I work on a translation of my book into French, and I know French, but my French is just not good enough to actually write a book in it, or it just would took too much time. So of course, I use an LLM to translate one paragraph in English into an equivalent paragraph in French. Then I read it. I see that nothing is broken, and I put it in my French version. So what's going on? I have a glossary that has maybe a couple of hundred terms in French and corresponding terms in English for AI and machine learning domain. And I would like this glossary to be respected because it's exactly the same glossary that I used in my first book. So I want them to be, equivalent, because in French, for the same English word, you might have five different translations, just like in Russian. So English is, like you walk on the side and you say it's a sidewalk, but it's not as simple. In Russian, you have a word for this, and in French, you have a word for that. So, like, just to have these two books consistent, I want my LLM to translate according to this glossary. So, what's going on? I give it not a lot. I give it maybe four paragraphs at the same time. And in my prompt, I say, when you translate, first of all, keep all the annotations because it's in markdown. So I want the word in bold to remain in bold. there are references to, to other sections of the document. There are references to the index, and also do respect this glossary. Okay, so translate according to it. So what I get, first of all, it doesn't respect it. So some terms were translated according to the glossary, some weren't. I tell it, okay, you didn't translate this term according to the glossary. Repeat. It repeats, so it regenerates. Now this word that I pointed to is translated well, but now it's in bold. I say you weren't supposed to add additional annotations, and it was among the instructions. Do not add new annotations. Do not remove existing annotations. And it says, okay, it regenerates, and now none of the words are in bold. And I talked to you not about, the model that was released 2 years ago. I talked about the frontier LLMs like Grok, like Gemini, like ChatGPT. So it cannot follow such simple commands. Okay, how can you, how, how dare you to predict that next year it will replace, a human in everything they do at their job? Like it's such a simple demand. Just don't screw with my annotations, and do use this glossary. How hard it could be. So your employee, if they make such mistake once, twice, 3 times, eventually you will tell them, no, I don't accept this, I don't accept that. Eventually they will do what you want, because translating is not, it's not rocket science. But this LLM, it doesn't learn. So you tell it was wrong, it will fix it probably, but in the next section, it will all be forgotten. There is no LLMs that learn from conversations for many technical reasons, and I don't think that it will ever happen. So no, I'm not in this spectrum. I just say that the technology is great. I love it. It changes how we work. It changes how fast we can get information. But all these predictions are lies. And I understand when CEOs of large companies like OpenAI, Anthropic, and others, they exaggerate. Okay, I will not tell the word lie. They exaggerate. I know why they do it, because they sell stocks, and they want to sell them for as high price as they can get. So the highest are your expectation, the higher are your expectation, the higher is your stock. But why those influencers do it? Like they just blindly repost everything, every lies they see. They do it probably for likes. And for me, this is the most disgusting thing. Like you don't even earn anything on it. It's just for likes, and you mislead people. You make people anxious without any grounds. I find it really disappointing.
But it's interesting, though, that thing about likes. And I agree, like, obviously, there are people out there, there appear to be people out there that are grifting away, just trying to, just get as much attention as possible. As you say, though, of course, there are going to be the people that make a direct financial benefit, or that they get a direct financial benefit, the CEOs. I don't know how long that actually lasts. So lots of people asking, like, well, how long can people possibly keep investing in these people and spending all of these billions without getting anything back? They're losing money on every new user. Like, you've got these new image models coming out that that Sam Altman's going online saying, oh, can you slow down, please, because you're costing us too much money. So, okay, cool. I get that. But I do think that there's also like this ecosystem of kind of almost in the same realm as you, but from the other side of, like, they want to write a book on it. They want to do a course on it. They want to, do a newsletter and charge for it. And again, I'm not going to say that people shouldn't be able to do that. I guess the thing that really bothers me when they do that is not that they do it, but that they do it from a position of seemingly not 100% knowledge. And it's fine to be excited. I like people being excited, but like you say, it panics people, it makes them worried, it makes them fear for things, and it also persuades non-technical people that have even less knowledge about this stuff that maybe they should start making decisions. And I read some posts the other day about, like, some companies laid off all of its engineers or whatever and replaced them all with AI, which is obviously nonsense. Like, that didn't happen. We all know that didn't happen. But can we confidently say that isn't something that someone would try to do? because that they've read an article on like Hacker News or something that says that that's a thing that they should try to do. So like there are real world effects of these things, I guess. And I guess that's the most frustrating thing. It's not that people are taken in or that they're excited or that they're interested. It's that these have a knock-on effect. And I don't think that people are thinking about that. But,
Yeah, well, it's a tool. As I said, it's a tool, and it's a very effective tool in some contexts. So when you actually interact with this tool, you learn in the process in which context it provides efficiency, in which context it's rather make you waste your time. So the more you use it, the more you kind of feel when to use it and when not to. So this is probably what differs from the hammer. The hammer, you know how to use it, but LLMs, yeah, the LLMs you don't know, because how can you use it is only defined by the training data that was used to train it, and you don't know what training data was it, and if even if you had access to it and they hide it because of the copyright infringement accusation, so they hide it. So you should guess, okay, maybe this kind of documents exists online, so I would still try to ask such questions. So it's a trial and error. So the more you use it, the more effective you become. But when I say you as a human being, okay, so like saying that eventually it will start thinking instead of you, it's a lie. And if you understand how it works and you still say it, like it's a deliberate deception, and it should be uh, punished somehow. But if you don't understand and you say it, well, you just do a disservice to the society. For what? I don't really know. So no, I disrespect people who either lie it for because they know, and I think it's crime. And I disrespect people who just say it without understanding, because there are better things to do in life than just deceiving people.
Here, here. Well, if people do want to come and understand it, obviously one of the ways that they can do that is come and read your book and hopefully read some of the equations, or if not, at least read the words around the equations. So if people do want to come out and check your work after this, or maybe connect with you, or try and have a chat or argue with you about some of your posts, or find out about all your books, where can they come and find you?
Well, it's easy. You Google Andriy Burkov, and you find a lot of links. But I am on LinkedIn very often, and I also on Twitter. And on Twitter, I often post something that I wouldn't post on LinkedIn, because I try to keep my LinkedIn communications professional, to the best of my abilities. So yeah, so to be closer to me, use Twitter to just stay updated on what's important. For you as a professional, you can just limit yourself to LinkedIn. And yeah, my books. Every book has its own site. The content of the book is entirely available on the website. So my philosophy is read first, buy later. So you can read it entirely. And if you feel it didn't serve any purpose, it was boring or whatsoever, you don't need to buy it. But if you feel like it was helpful, it allowed you to become a better person, a better specialist, then consider buying it, because this is what I do for the living.
Absolutely. The even though the kids are at college, you still got to feed got to feed and buy them presents for Christmas and stuff as well, right? So it's all important to get that money pot filled back up, especially now that you're out on your own. Well, I'll make sure to link all of those different places into the show notes, and hopefully some people will come and give you some attention. No pun intended in LLM terms. Well, Andriy, it's been a pleasure to chat about all things language models, large and otherwise, and beyond. And obviously, wishing you the best of luck with your future career direction. I'll obviously be watching and seeing what happens. Hopefully, we can stay in touch. But as for now, thanks for taking the time.
Thank you, Jason, for having me. It was a pleasure to have a discussion.